Right, so we have two methods for call detail records we support. One is text call detail records and one is radius. Or we call it radius accounting when we talk about CDRs. So when we receive, when we want to use text CDRs, we will configure the system so that it has text CDR enabled, okay? It will generate flat files of CDR data. So these will be just like text files with all the data about start and stop of each of these calls. So at the start of a call, it will print an entry in the file, and when you do stop, it's going to do a stop in the file. On a complete call, like from an incoming leg to an outgoing leg, it's going to create 4 entries. One start and one stop for the incoming call, and one start and one stop for the outgoing call. So for each of those calls, you will have 4 entries. And these 4 entries can all be linked together with a parameter that's called the session ID. Okay, so the session ID will reference all those calls together. In addition to this, you can add a progress so that every X amount of time after the start, we will send another input into the file to say the call is still ongoing. Okay. So as you can see, the files are all stored locally on the SBC, and I will explain that in a minute. When we use radius CDR, we will use an external radius server, and now we call it an accounting server because that is what is used for call detail records. So we will send radius accounting request to the radius server every time there is at the beginning of the call and at the end of the call for the incoming and the outgoing leg. That means there will be 4 entries for each of the calls that are successful. If there's a call that is refused, let's say, for example, there's an incoming call and it never gets routed outside, then you will get only a stop event from the incoming leg saying that this call has not gone through. Text CDR, like I showed you, are stored locally on the file system. So it's stored on a specific location on the disk, and we fill up a file, and then you can configure when this file would be rotated. And every time the file is rotated, it's compressed on the disk, and it will stay there unless you do something to extract these files from the unit or push them outside of the device. Okay, otherwise they will stay there forever. Well, not forever. It depends on the parameters you have set for file rotation and maximum file on the reserve for the call detail records. You have configurable CDR parameters. All right. So in the configuration of the system, we have set up default information, which is good enough in most cases. But if you want to have exactly the information you want, you can just go there and modify it. And here I just give an example, start time. So that's the time when the call was created. But start time, there's 3 different formats we can use. One is just a timestamp in seconds. One is a timestamp formatted. So it looks like this, right? And this one is the same as this one, but UTC time. So instead of using the time zone that you are in right now, it uses the UTC time zone to mark that packet. Other CDR parameters that can be put in the files. You can have the local and remote SIP IP and port. The RTP IP and port that was used for this call. You can input there which vocoder was used. So for example, if you use G729, it will show in there that's what was chosen for this call. And at the end of the call, you can also get call statistics. So for example, how many RTP errors happened on this call, how many sequence errors, lost packets. You also get statistics on number of RTP packets received or sent, and the MOS score can also be stored in the call detail records. So some of them are input by default, but you can have more details about those call detail records if you choose so. Okay. So yeah, let me just show you on the wiki. These parameters are here. So if you go on TechCDR, you will see the variables that are being used in the system. So you have, for example, status type, leg ID, other leg ID, session ID. And then I showed where is start time. Start time is here. So start time format, start time UTC format. Each one of them is described on what it is. Okay. So you have the call number, calling number, termination cause string, SIP port, SIP IP, media information. All right, so the list is here. And then in addition to this, you have call statistics information. So if you click on this, you will get all details about the MOS, network quality, receive packets, convert noise packets. And so you can go as much in detail as you want to in the call detail records data. Okay. So to configure TechCDR, you have to go here in Gateway, select Use CDR Behavior, and this box will appear here, and you need to choose the CDR mode. So if you want to use TechCDR, you can click on this one, TechCDR only. But if you use radius, well, then you can use here, choose radius only, or radius CDR with TechCDR fallback. So that means if the radius, the CDR cannot be written to the radius server, it will go back in the text CDR. Whoops, it's reversed. So when you click on TechCDR, you will also see this box, which will show what will be printed for a start entry. And you have the same thing for the end. Okay, so for start, you have a timestamp. So every time you see at like this, that means this is a parameter that is taken from the SBC core And if you have something like this, comma, BEG, comma, session ID, this is just something that will be printed in the CDR. So here you see comma, BEG, comma is printed here. So that's a begin start entry, okay? But here in this case, session ID was not put here. So, okay. But anyway, add session ID, leg ID, start time, connected time, and you see all these information here being printed in the text file. And here it says where these files are located. But if you just search for CDR logs, you will find them. Okay. So by default, the CDR logs are rotated and zipped every 1 hour. And the total folder size is 10 gigabyte. These files can be retrieved manually by connecting with SFTP and going to the directory. So this is the default directory for the CDR logs, and you can get all of them. They will be just here. Normally, when you download those files, you should erase them because otherwise it's just going to grow forever. It's going to fill up the 10 gigabyte and then it's going to be overwritten by new ones. So it's a good idea to just download and erase those files. So to retrieve manually, you connect FTP to the SBC and then you download those files. The other way to do it is by using automatic text CDR retrieval. So what we can do here is use a little application that's called TB Copy CDR. And TB Copy CDR is used to take all the CDR files that exist in the SBC and push them out to a remote server. So this is just a CentOS shell script. In there, in that file, well, first you need to create a key, an authorized key, so that we can push this file without user password information. Once you have done that, then you can configure the shell script that's called TB Copy CDR and change a few information in there. For example, the remote host directory, the remote host IP, and we want to erase the files after sending them to the server. Okay, so you open up this shell script, you change those parameters here, then you just need to use a cron job to run this TB Copy CDR application every X amount of time. So in this case, it's going to be every 10 minutes. We will run this file. It will search through all the CDR files that you have currently on the system, and it will push them out to a remote server. Once they have been pushed out, if you have selected erase after send here, it will delete those files. Okay. On a 1+1 system, the CDR entries will be on one system only. So because the gateway application runs as a 1+1 active standby configuration, only active one will keep the local CDRs. So if you need to have, to make sure that you get all the call detail records, in case of a fallback, both systems need to have this cron job enabled. Or if you use SFTP, well, you need to go on both servers to get the data. So let me show you here. If you go in the gateway application here and you select use CDR behavior, right now it's unchecked. So if you use if you do use CDR behavior, it's going to open this box here. Then you need to choose the CDR mode here, which is if you use text CDR, you have to choose this one. And then, as I said, you can change the start format here on what you want. If you're using update, you can change this. And the end format, and you see there's more information on the end format. We will display remote media information, statistics on how many packets that transmitted, received. Well, these are T38 packets, but from network to network, the MOS score, the network quality. So all of this will be printed by default, but this can be changed with the values I showed you here in the wiki. All right, so you can choose what to show in the logs, the CDR logs. And you see below here, you have the rotation delay. 1 hour is the default, but I've seen a lot of customers use 5 minutes instead. So, so like this, and then you have total logs in a folder, and for each file, maximum size of each file. So you can configure all of this. Then you have TB copy CDR. Okay, and if you verify this file, all right, so it's, you see it's a shell script like this, and they are just a few parameters you may want to modify, and they are all in the same segment here: the remote host IP, the remote host port, the directory of the destination. Here we have put the user as well, and but it still needs to have the keys. Okay, so these are the only parameters you need to change here, and maybe also erase after send, true or false. And the rest will work automatically. So the rest of the script will be working. Okay, Radius, we saw already that we can do Radius authentication with the routing scripts. Okay, and we can do also accounting. Okay, well, we can do authentication and authorization for routing the calls, and we can do accounting to get the call detail records in the system. All right. For some systems, it's critical, of course, to have the call detail records to be able to bill all the customers. So here, I just want to show that the SBC is a Radius client, and the Radius server is provided by someone else. And for authentication, we saw that before, and it's defined, I told you it's defined in an RFC, it's RFC 2865. And we saw before access request and access reject or access accept. Okay, and this is returned to the client. So we can use this in our case for routing. For accounting, it's another RFC called 2866, and then we send an accounting request instead of an access request. And we put some attributes there, and the attributes in an accounting request will be the call detail record information. and then you get the accounting response from the radius server, which is, in this case, basically only accept the accounting request. I don't know if it can really refuse the accounting request, but it just acknowledges that it has received this accounting request. And if it doesn't respond, then we'll try again to send it to that radius server. Okay. So these two RFCs are supported by the ProSBC. Okay, so radius accounting, we use it to get the call detail records from the SBC to a radius server. And we use the dictionary from the RFC 2865, the RFC from 2866. We use an additional dictionary from Cisco because it had useful information in that dictionary. So we use some of those. And we have defined a specific Tech-Bridges dictionary for radius accounting. All right, so if I show you quickly the attributes that are in each of those RFCs, I think I showed you those ones already, like the call station ID. We mark it as call number, calling station ID as a calling number. So these are standard authorization requests for radius. And then accounting, we use those ones. Accounting status type, start or stop. Accounting session ID, we use the call leg identifier here. And accounting session time, we use the duration of the call in this parameter. We use also, these are the Cisco ones. Yes, these are the Cisco ones. We use the conf ID. We use the incoming conf ID. And this one is important because it's the unique call ID that references the incoming and the outgoing leg. So this one is important. Yeah, so we use also setup time, connect time, disconnect time. Okay, so these are all things that we use from the Cisco dictionary. And we have our own set of attributes. All right, so as an example, we have timestamp, media information, so the IP and the codec used for the call, the SIP IP. So similar to what we get in the tech CDR, but we have it here for radius. Okay, so if I go back here in the wiki for radius CDR, so you have all the list here, the ones that are from RFCs, the one that is from the Cisco RFC. And you see we use some of them here. They're all described. And if I go down, we have our own definition here. And of course, the radius accounting server needs to understand these parameters. So it needs to load our dictionary here to be able to understand all these parameters. Okay, so it mentions here that the radius dictionary is located on each of the devices of our SBCs. Okay. Whoops. Okay, so you can in the radius you saw we in the routing script we can assign some radius authorization servers. Here, what we will do is the same thing, but we will name them as accounting servers instead. So, and then you can have only one like this, or you can have as many as you want. So most of the time, customers have two radius server. The first one will be up and available, and it will be the current one. So that means all the radius CDRs will be sent to the same device here. And the secondary one will be up and active, meaning it's ready to receive traffic. In this case, we have a third one also that is ready here. Then if the first radius server becomes down, so we try to send some request, there's no answer. We try to send some polling, there's no answer. Then we will stop sending to this radius server and start sending or resend all the CDRs to this device. So we have some buffering that is done here on the SBC, and if we can't send them near, all of them will be resent to the second radius server. If ever they all come down and you have chosen to do text CDR fallback, then if the packets can't reach the radius server, it will fall back and create some flat files on the system with all the data about the CDRs. So I showed you already the radius configuration, but here the difference is that you will select accounting here instead of authorization. Okay, so yeah, okay. And the other thing I didn't mention in the other presentation is if your radius server is located outside and you have a firewall between you and the radius server, you may need to do something like this. So input a public IP address, which is similar to what we do with netting on SIP and RTP, but this one is specifically for radius. So this will be your public IP where you will get your radius packets returned from the radius server. You can define if the server port is not the default one, number of retries, the timeout that you will use to try to send those packets. And if you want to poll the radius server, it's going to use a special radius request that's called status server. And by default, it's 5 seconds. It's going to send every 5 seconds a status to see if it's up. And as I said, there's a secret to encrypt the data that is sent on radius. Okay. That's another thing you have to put in the Wireshark to be able to decode the radius packets in Wireshark. Okay. Otherwise, you will see only the main the method that is being used in radius. You won't see the content of the packets. Okay. Yes, so I spoke about that just a little bit. So if it's up, it means we got a response. If it's down, means that it doesn't answer anymore. And unknown means we never tried or never been able to send any request to this destination, and it may not even exist in the network. And then there's 3 states: current, meaning that is currently being used; active, it's a candidate as a backup device; and inactive means that it has been manually disabled. All right. So this is one thing I did not mention yet. When you go in the status portion of the web interface, you have some cases where you can set some values. Like for example, here, if I click on the state here, I can say current, inactive, or active. So here I can say, well, I want this radius server to be inactive. All right. So you select inactive and you click on apply states, and this will immediately render this radius server inactive. So there will be no more requests sent to this radius server. So this can be useful if you want to do maintenance on this radius server. You can set it to inactive. Any new radius server request will be sent to the standby one. And then you can fix or update the primary radius server. And then you can do the same thing on the other. Put this one back as current and or active, and then apply states. When you do apply states in a status page, it is always immediate. All right? So you don't need to activate the configuration. So apply states will do it right now. All right? So this will allow you, for radius in particular, it will allow you to choose which one is the current one, and if you want to disable one as well. Okay, so explanations on current, active, and inactive. You have also other information about the status. So you have, for example, how many accounting records you have instantaneously, how many are queued. Right? So this is important because if this number grows, continues to grow, at some point you will go over the queued limit and it's going to cause a problem, right? So if ever there's a problem in radius, you maybe will be able to look at this. Total request, failures, retransmission. So you can see all this information here. So troubleshooting on the radius capture, you can do depending on, is it, like I said in previous presentation, if it's on a management interface, you can do a TCP dump because that's a CentOS regular, nothing fancy there. But if you are using an IP interface, a LAN 1 IP interface to send the radius information, then you need to do a TB router capture. This is the link to get this, to explain how to do the TB router. But as you have seen yesterday, you use the tool TBX CLI Tools Remote. You select TB router and you press P to start the trace. Okay. And also P to stop it. There is a tool that you can use that's called a P-Link to do a live Wireshark capture. So what this, okay, so this tool is provided by the same team that did PuTTY, okay? And it basically does a connection on the server, whoops, with the password. Okay, does a SSH connection on the server. So you need to have the SSH access to the system. Then it does a specific command. So in this case, it's a TCP dump command, but you can use also a TB-sig trace. And I will show you tomorrow how to use TB-sig trace. And this is management 0. Management 0, so that's capture management 0. So this, you see this TCP dump command here is the same as this one here. And then the next part of this is a pipe here pointing to your Wireshark application. That's like the default path for Wireshark. And you need to add those parameters. When you get all of this line correctly, you will get a live Wireshark capture of your radius traffic in this case, and or your SIP traffic. Okay. So maybe I can just show you quickly. Oops. If I show you VMA1, for example, and I have my TB6 tray. So what I did myself is I created some automatic links to do that. So when I click on my link, it starts automatically the this P-Link application. Do we see it here? No, we don't see it. No, but anyway, you saw it started my Wireshark automatically, and then it says capturing from dash. You see the dash here? That's the dash that is in the command. Oops, where is the command? The dash, the last dash here, right? So this tells you capturing from this interface. So what it did, it connects SSH to the device. It starts the signaling capture and then pipes the output. Instead of displaying it on the screen there, it pipes the output back to my Wireshark application here. And so you see, you can hear filter on registration requests. So you can see all the registration requests that are being sent to the system right now, and or options or no options. So you can see all the requests that are done without any options. I also see the DNS queries that are being done here, right? So in our case. Okay, so it's very useful. It takes a few minutes, I would say, to set it up because the line is pretty long, easy to make a mistake. But once you get it running, it's great. Okay. I will show you other examples tomorrow. Okay. Other things you can do, and I mentioned that a little bit in the routing scripts, you can insert custom values in CDR. So one thing you can do directly from the routing table is add a new custom attribute. So for example, here in trunk or whatever, it doesn't matter the name of the attributes here. You just need to add in your text CDR the parameter route attribute and the parameter custom attribute or any attribute that you have been using here. Okay. So you can do that, and this information will be printed in the text CDR. Okay. This is the good example here. Route attribute in trunk. Okay. So you use the custom attribute that you have put here, and in the CDR box I showed you earlier on, you just add this, and it's going to display this value in the call detail records. Okay. If it's the route name, then you just need to put here, and the route name is actually this name here. Okay, so if I just, the route name that you put here is the route name that you have put here. Okay. So two ways to do this. And so this is straight, right? You don't have to do any routing script or anything. You just do this and that works. However, you can also do it in the routing script to do other things, like, for example, a specific script attribute that you want to display in the text CDR. And one example is something that is received from the incoming leg, and you want to push it into the CDR. So you can do something like this. The script attribute is the name that is being used in the script, and this will be pushed in the CDR. Okay. And okay, so there are actually two things to do. One is in the text CDR box, you need to add this, which has the variable name. And in the script, you need to have this line, which is a variable name, link it to the bridge information. Okay, so when it goes to the CDR, it will be pushed as the same name here. For radius, it's the same thing, right? Instead of using a variable name, you need to use the custom CDR value. So this is a very specific name. You cannot change this one, but you can set any value here to this, assign any value to this parameter. And then in the radius accounting, it's going to be sent as this value. So this is a global parameter, and this is a per route parameter, and you need to specify which route will use this value. If you need to do this for radius CDR, we can, or from text CDR, we can, we have some sample scripts, and we can make that available to you. Oh, there's a question from Lilip. Let me just check if I can find the answer. If I go here in the radius configuration, yeah, okay. Yes. Okay. So then I think we cannot choose the source IP interface. Let me just, I'm not sure why I cannot choose my IP interfaces here. Yeah, I don't know. Maybe I'm missing something, but let me check here. No. The only option I have right now is any, so I'm not sure. Okay, so you showed me also how to add a dictionary for a radius server. Here I have none available, but you can click here on manage directory dictionaries, I mean, and I'm now in FileDB. You see we imported custom files this morning, and then digit map files later. And I can also import a radius dictionary here. And I just need to make sure I also set it here once it has been uploaded in the system. Yeah, so Lilip, the answer is it looks like I can only choose any. So that means if we set an IP here, it will try to use a network which corresponds on the IP interface. Otherwise, it's going to use the default route to send that, which is the management interface. Okay. So I covered the CDR presentation. Any questions on this or any other subject we touched on today?